Okay, this is 8th grade lesson 6.4. Today, students will use properties of square roots to simplify expressions. The standards covered in this lesson are 8 and S2. The page numbers out of the hardcover book are pages 252 through 257, and out of the practice journal, pages 129 through 132. Today, we're going to be working with we'll start out with simplifying some radical expressions. So radical expressions are going to involve square roots and cubed roots and so forth. We'll be mainly working with square roots today. The key thing on these is to understand that you understand the basis of this based off of like terms. So before, when we would work like terms, well, what would we do to simplify like terms? We're going to use that concept to actually work in radical expressions. So if we had 5x plus 4x, we know that when they've got the same label, as long as they have the same ending or the same here, they both have x's attached to them, we can go ahead and add these front numbers. Okay, so 5 plus 4 would give us 9x. This is simplifying like terms. We're going to use that same concept to work with simplifying radical expressions. Okay, we're going to think of those square roots as labels, kind of like we did here with the x's. So here, if I have this letter A, it says simplify 5 squared plus 4 squared. Taking note, this is kind of like a label. Okay, they're the same square root. They have the same number underneath of the radical symbol. So I'm going to go ahead and just add my front numbers. So 5 plus 4 is going to give me 9 times the square root of 2. This is all the further we're going to go right now. Eventually, as we progress in our mathematics, we will continue to work a little bit further, because really that means 9 times the square root of 2, but that's not a perfect square. So we're going to go ahead and just leave it as the square root of 2, okay? So here, our final answer for right now when we're simplifying is 9 times the square root of 2, or right next to the square root of 2. Okay, so let's go ahead and try another one. So here it says simplify 2 with the label or the ending of the square root of 3, and 7 the square root of 3. Times. Really, there's no symbol there. There really is multiplying involved here, but we're just going to simplify. We're not actually going to get our final answer. Oops. So we're going to go ahead and just look and say, okay, they both have a square root of 3. So we're going to follow what it says to do. 2 minus 7. So 2 minus 7 would give me negative 5. So my final answer is negative 5 with a square root of 3 attached to it. Okay, so it's pretty simple, just understanding right now that we're working with something that looks very similar to like terms. Okay, so this one looks a little bit tricky because we have no number sitting out in the front. So what does it mean when there's not a number there? It means that there's actually a 1. Remember, you can take 1 times anything and get the same number. So when there's not a number in front of that radical symbol, go ahead and put in a 1 if they're asking you to simplify. It's going to help you to remember there really is a 1 there. So here, now when I look at this, they both have the square root of 5 attached to them. So we're going to do 1 plus 1, which would give me 2 square roots of 5. So this is my final answer for right now. Okay, so it's a pretty easy concept. So I'm going to slide a couple out here and have you guys try this concept independently. Okay, so go ahead and try these two. And then when you're finished, you can start your video back up and check yourself. Remember, if there's no number, it's the same as having a 1. So you should have gotten 10, the square root of 10, and 1 times the square root of 7. Okay, so that's just simplifying radical expressions. Once again, you will continue as you evolve in math, you'll continue to work with these at a more advanced level. Right now, we're just going to simplify them. Okay, so in order for us to be successful in the next part of this lesson, we have to review prime factorization. My hope is that I have gone through this with you, but if you guys are ahead of me in terms of where we're at with our computation review stuff, you may be needing to review this independently. So we're just going to review it in this lesson. So prime factorization is breaking a number down into all of its primes. So one concept is to do a factor tree, which is the method that I prefer. You can also use the division method. To me, the division method is when you write out 81 and you only divide by primes out here. I'm not a super fan of that one just because if somebody is not careful, sometimes they divide by a non-prime number. So what are prime numbers? Prime numbers are those numbers that cannot be broken down any further. Examples would be 2. 2 can't be broken down any further. 3, it can't be divided out any further other than having 3 in itself as factors. So those would be prime numbers. 4, for example, is not prime. That's what you would call composite. It's composed of other numbers because 4 could be broken down into 2 times 2, okay? You could also do 4 times 1. So once they have more than one factor, they're no longer considered prime numbers. So we're going to go ahead and break this down as far as we possibly can. So I'm going to use the factor tree method. So this method, as you're working through it, if you break it down differently than I do, we're still going to end up with the same answer in the very end as long as we both did our math correctly. So when I think of 81, well, what number times a number gives me 81? 9 times 9 is the one that pops into my head. I may have somebody else. I'm going to show that no matter what I do, I'm going to get the same answer either way. Maybe somebody else said 27 times 3. Probably not super likely that somebody does that, but they may, okay? So now I'm going to continue to break down each level of this tree until I can't break it down any further. And when I can't break it down, I'm going to circle that number. So here, 9, I could still break down because 9 is the same as 3 times 3. Okay, so I can break down this 9, 3 times 3. Now, can I break 3 down any further? No. The only way I can get 3 is 3 times 1. So this is a prime number. So my prime factorization is finished on this one. Okay, I've got 3 to the power of 4 would be the prime factorization of 81, or I could write it out as 3 times 3 times 3 times 3. We're going to be leaving it in this concept for the activity that we're going to do next in this lesson. Okay, so now if I continue just on the other way that I had broken this down, this 3, it can't be broken down any further, so I'm going to circle it. And for 27, that would be 3 times 9. Okay, that 3 can't be broken down any further, and 9 is 3 times 3. Take note that I ended up with the same answer either way. I still had 4 3s. Okay, so the way that you initially break it down and how you choose to break it down by its factors is up to you. In the end, we should all end up with the same answer. So we're going to go ahead and practice this concept as a review. And for some of you, it may be initial teaching also. Okay, so let's try this one. This is a big number. And yes, you can use your calculators to help you on this. I'm not expecting you to know numbers off the top of your head. So if I'm using my calculator, what I'm going to do is I'm going to punch in 945. So 945, and I want a number that will go into that. Well, it ends in a 5, so I know that 5 is going to go into that, so I'm going to use 5 as one of my numbers. But I need to figure out what I'd have to take 5 times. So I'm going to punch in 945 and divide that by 5, and that gives me 189. Okay, so I have 189 there. Now, can 5 be broken down any further? No. I can only do 5 times 1 to do that. Okay, so for 189, if I want to break that down, I know it looks like a weird number. One concept is you can go through and check some of the rules. Well, one rule is if a number can be divided by 9, for example, is if the sum of these can be divided by 9. So 9 plus 8 plus 1 gives me 18. 9 would go into that. So I'm going to try 9. Not try it. I know 9 will go into it. So I'm going to take 189, which is still on my calculator, and hit divide by 9. When I do that, I get 21. The key thing on this, you can never have a decimal number. Once you hit a decimal number in there, you've done something wrong, because that means that that number can't be broken down by that. Prime factors are going to be whole numbers that will go into that number. So now if I break this down, 9 would be 3 times 3. Okay, 3 can't be broken down any further, so I'm done. 21 would break down to 3 times 7. Okay, these are the lowest number. Those are prime numbers. So my prime factorization is 3 times 3 times 3 times 5 times 7. So there's my prime factorization. Another method that this may be written out, maybe if you're doing standardized testing, would be 3 to the 3rd power times 5 times 7. Now with the activity that we're going to be doing later in this lesson, we want to leave it in that format because it's going to help us to be able to break into pairs or partners. Okay, so let's go ahead and try another one here. That one was a pretty big number. I promise we'll do some easier ones. Okay, so 234. So ends in an even number, so that means 2 will go into it. So we're going to practice this concept. So if I punch in 234 divided by 2, because I'm going to use 2 to start out with. 2 is prime, so I'm going to circle it. And when I divide that by 2, it gives me 117. Okay, so 117, once again, kind of a tricky number. So when I look at this, rules that I check, does it end in 2 or end in an even number? No. Does it end in a 0 or a 5? No, because that would tell me that 5 would go into it. So then I tend to jump to my next rules would be if I add the digits together, so 1 plus 1 plus 7, either and 9 or 3 will go into those, then I could divide by 9 or 3. So let's see, 7 plus 1 plus 1 is 9. So I know that 9 will go into it. Okay, so I'm going to hit 117 divided by 9, and that gives me 13. 9 can be broken down into 3 times 3. 13 can't be broken down, so we're done. Okay, so my prime factorization would be 2 times 3 times 3 times 13. Or another method would be to write it out as 2 times 3 squared times 13. But once again, for today's lesson, we're going to leave it in that top format. Okay, because we're going to be doing another step from that. Okay, so I'm going to slide one out here that I want you to try. Okay, so go ahead and break this one down. Okay, 125, break it down into its prime numbers. And then when you're finished, start your video back up. Okay, so this was working. When we broke it down, we ended up with 5 to the third power, or 5 times 5 times 5 was 125, broken down into its primes. Okay, so we're going to be using that concept in this next step, where it's asking us to simplify square roots. So remember, a square root is the opposite of a number squared, right? So they're going to give us some that are not perfect squares. So here, 80 is not a perfect square. They don't really want the decimal number of this, so they don't want you to go through and use your calculator to punch in the square root of 80. They're going to ask you to simplify down the squares. So it's going to end up looking like something that we worked with back a couple slides, where you have a number on the outside of the radical symbol and then a number underneath, okay? So we're going to have to use those steps that we just did, that prime factorization. So I'm teaching this slightly different than the book. If you get confused, you can go into the book and work that method. But the reason I didn't like the method that the book was using, it just left too much room for mistakes. The prime factorization method, it's unless you mess up between your prime numbers, there's very little mistakes that can be made. Okay, so here, if I do the prime factorization of 80, well, it ends in a 0, so I know 10 will go into that. And that would be 8 times 10. Okay, can I continue to break those down? Let's see, 10 would break down into 2 times 5. Okay, 2 is prime. It can't be broken down any further. 5 is prime. Okay, so for 8, so let's see, 8 breaks down to 2 times 4. Okay, 2 is prime. 4 will still break down to 2 times 2. Okay, so I'm done with my prime factorization. So I'm going to go ahead and I am going to write this out so that I can see all of the numbers in a row. So 2 times 2 times 2 times 2 times 5. Now, I know that I could write that out as 2 to the power 4, which is how you would see it if they just asked us to do the prime factorization. The reason I'm not going to have you do that is now my next step is I'm going to go ahead and partner up common primes. So numbers that are the same, I'm going to put them into pairs. Okay, so let's see. Here's a pair of 2s. Here's a pair of 2s. And then I have a 5 left over. Okay, so my pairs, I'm going to put outside on the outside of the radical symbol. So here's my radical symbol. And I have a set of 2 and another set of 2. So I have a 2 times a 2. Yes, you're only going to write this 2 one time. Why? Because underneath of this square root, this is what it looks like right now. okay? Remember, the square root is the opposite of something squared, okay? So if I'm gonna go through and do that, what I'm saying here is 2 squared is one of those is gonna take care of one set underneath. So that's why I'm writing it out once. So the key thing here is I'm just gonna go ahead and write out, if I have a pair, I just write that number once for each pair, okay? Whatever's left over, I'm gonna write underneath the radical symbol, so I've got a 5 underneath of here. Okay, so now I'm gonna simplify where I can, and that would be, well, there's nothing left to simplify with the 5, but I could simplify out in the front, 2 times 2, which gives me 4, and then I'm gonna write the square root of 5. Okay, the way that they taught out of the book was they asked you to list all of the factors of 80 and then find perfect squares. To me, it just left too much room for error if somebody didn't pick the perfect set. So that's why I went ahead and chose to just do the prime factorization. It's very visual where we can find those perfect squares by doing the partner concept. Okay, this is my final answer, 4 to the square root of 5, or with times the square root of 5. Okay, so let's go ahead and practice another one of these. Okay, so first step, we're gonna do our prime factorization of those numbers underneath. Okay, so 300, let's see, that would be 3 times 100. You could break it down into 60 times 5. I see 3 times 100. Okay, in the end, we should get the same thing. Okay, 3 is prime, can't be broken down. 100 could be broken down into 20 times 5, 10 times 10. I'm gonna use 10 times 10. Okay, 10 can be broken down into 2 times 5. Okay, these are prime. They can't be broken down any further. So now I'm going to go ahead and write everything out. So really what I have is the square root, and then I've got 2 times 2. When you're writing it out, putting them next to each other so that it's very easy for you to see the pairs. And then I've got times 3 times 5 times 5. Notice, although I had my 3 clear over here, I still put them in order from smallest to largest. I put numbers that were the same next to each other. Okay, so now I'm gonna look underneath there and I'm gonna see if there's any partners. Okay, here's a set of 2s and here's a set of 5s. So on the outside of my radical symbol, I get to write each one of those sets. I just get to write the number once for each set. So a 2 times a 5. And then whatever's left over that I didn't partner up, so those are gone and those are gone, I'm gonna leave under that radical symbol, which is a 3. Okay, my next step is to now simplify each set. So there's nothing more to simplify with the square root of 3. There's not another number underneath of there. 2 times 5 would give me 10. My final answer is 10 to the square root of 3. Or times the square root of 3. I keep saying that incorrectly. Okay, 98. Once again, you can use your calculator to help you break down into your factors. I do not want that the square root of 98 is, let me see what it would be. I don't want the answer as 9.89. I want you to break it down so that you're left with that non-perfect square. Okay, so let's see, 98, if I break that down, it's an even number, so I'm just gonna divide by 2. So 98 divided by 2 is gonna give me 49. So 2 times 49. 2 is prime. 49 breaks down to 7 times 7. 7 is prime. It cannot be broken down any further. So what am I left with? 2 times 7 times 7. Okay, so I wrote out everything in order. I'm now going to see if I have any pairs. I see there's a pair of 7s here. So I get to write that once on the outside of the radical sign. So 7. Whatever's left over is going to go underneath or behind that radical sign, which was a 2. This is my final answer. This time I couldn't simplify in either set because there was no other numbers on the outside or underneath. So 7 times the square root of 2 is going to be my final answer. Okay, square root of 45. So the more you practice these, the more some of you are going to be able to kind of piece out and find those perfect squares within that. If I were to go through and just think, are there perfect squares that are within 45, I just think of, well, 9 times 5. I know that this is a perfect square. That's the way the book wanted me to do this with you, but I just felt that that was very confusing. So that's why I'm choosing to do the pair thing. Some of you are going to be able to do this concept. So if you'd like to try that, you can try it out. You could go back and look at the book and see how the book is doing it. Some of you are just going to be able to visually see, hey, I know 9's a perfect square, and that's 3, and then what's left over is 5. A lot of you are going to need to see it this way. So if I break it down, 9 times 5, 5 is a prime number. 9 breaks down to 3 times 3. Those are prime. So I'm done. So I'm going to write it out. 3 times 3 times 5. Okay, do I have any pairs? Yep, there's a pair of 3s. So where do they go? They go on the outside of the radical symbol. And then I just have a 5 left underneath, so we're finished. So the square root of 45 is 3 times the square root of 5. And we're just going to leave it as that. We're not going to break it down into its decimal number. Okay, so I want you guys to break this one down. So go ahead and pause your video, work your way through prime factoring out, and then see, start your video back up to see what your final answer is. Final answer, you should have ended up with 2 times the square root of 6. So remembering that if you have numbers left underneath or behind that radical symbol, that like here I had 2 times 3, I have to go ahead and simplify those also. Okay, so that's working with simplifying square roots. Now what they're going to ask us to do is they're going to have us kind of combine some of those things where they might have us simplify and then also have us work like we did on the first part of the slide where we were combining or simplifying. Okay, so sometimes we have to work with simplifying square roots that don't have perfect squares. Now you guys have worked ones like this before. When you learned them earlier in this chapter, I gave you perfect squares, so it was something like this. Okay, remember when we worked with that, I told you that it might be easier for you to look at it as a square root of 9 over a square root of 25. And then you could go through and simplify. Okay, the square root of 9 is 3, and the square root of 25 is 5, and this would be my final answer. So we're going to still use that same concept, but then sometimes they're going to be leaving that square root as a non-perfect square. So we're going to have to check to see, does it break down any further? And if not, then we're just going to leave it as that square root within our fraction. Okay, so here we have simplify the square root of 11/16. So we're going to think of it like this. We're going to think of it as the square root of 11 over the square root of 16. Now, within that, can we break it down? 11 is not a perfect square, but 16 is. The square root of 16 is 4, so that's how we got the 4 there. Square root of 11 cannot be broken down. 11 is a prime number, so that's the lowest that it will actually go. So this is just going to be our final answer. Okay, we're going to start out pretty basic with this. Eventually what they'll start doing is later on down the road, you'll start working with some fractions involving those square roots and so forth and simplifying within that. Okay, so we've got the square root of 13/4. So think of it like this, the square root of 13 over the square root of 4. And some of you are going to be able to look at that and just do it. And some of you are going to have to do like I do in red, where you break it down into 2 pieces. So the square root of 13, well, 13 is a prime number that cannot be broken down any further. Okay, so 13 is just going to stay on the top. Square root of 4, is that a perfect square? Yes, it is. Square root of 4 is 2. This is my final answer, the square root of 13 over 2. Okay, so now we've got the square root of 35, 36. So some of you need to see it like this. Okay, so now if I go through 35 breaks down to 7 times 5. So that can't be broken down any further. So that's going to have to stay, square root of 35. If you check it on your calculator and it gives you, and it gives you a decimal number, then you have to leave it. Doesn't mean that we might not be able to break down, whoa, my goodness, that we won't be able to break down some of those square roots. But for right now, they're not going to have us go to that level yet. Okay, 36 is 6 times 6, okay, or 2 times 3 times 2 times 3. So it's the square root of 6 is actually 6. This is my final answer. I'm not going to go any further. Okay, you can use your calculator to help you, like if you're not remembering. I'm hoping you're remembering those perfect squares because they're your basic computation mathematical facts. Okay, so here we have the square root of 5 over b squared. Ooh, they're throwing in a b there. So let's remember that anytime we have a square root, the opposite of it is something squared. So those two will cancel each other out. Okay, this and this are going to cancel each other out. So I am left on the bottom with just a b. On the top, the square root of 5 cannot be broken down any further. So I'm going to leave it as the square root of 5. Final answer. Okay, so what does that mean? Let's say I threw in a number, like let's say I put 7 where b was, just so that you're understanding my little cross-offs here. If I had put 7 here where b is, 7 squared is 49. What they would have had was 5 over 49. Is 49 a perfect square? Yes, it's 7. Okay, ultimately what happened is this squared was canceled out by that square root. So that's what left us with just the b. Okay, so I want you guys to try these two. So go ahead and pause your video. Work your way through these two, finding the square root. Remember, most of you are probably going to have to see it in this format so that it's not overwhelming and thinking of it as this big fraction. Think of it as two pieces, one on top of the other. So go ahead, pause your video, work your way through this one, and then start your video back up to check your answer. Okay, so your final answers here were the square root of 7 over 25 and the square root of 67 over 10. Okay, so that's it working with fractions. I know sometimes they throw that fraction part in there and they make it look so confusing and you feel overwhelmed. But remember, I try and break it down for you to make it based on what you've previously learned, okay? So we have one more concept that I wanted to go over, and this is just a real world application. So we'll practice a couple just in case you come across something similar to this. So it says find the volume of the rectangular prism. So first of all, how do we find the volume of a rectangular prism? Well, we take the base times height times width, length times height, however you want to look at it. So it shouldn't be base, it should have been length because base is the bottom of something. Length times height times width, or length times width times height. So when we do this, we want to multiply all of these out. So we're going to take this times this times this. So underneath my square root sign, I'm just going to write each of these numbers. So I've got 5 times 10 times 2. Now, why can I write them underneath the square root all at the same? Because they're all under a square root sign, which means I can place all of them under the same radical symbol. So now, can I simplify this out any further? Yes, we can go ahead and just multiply this out. So 5 times 10 is 50 times 2 is 100. So I get the square root of 100. Can we break that down? Is that a perfect square? Yes. That equals 10. There's the volume of my rectangular prism is 10 meters. Okay, so let's try one more of these. I'm just going to change one of these numbers. So instead of that 2, let's change it to an 8, square root of 8. Okay, so we're going to go ahead. What if I change the height, this right here, to an 8? So this is going to be the square root of 8. Okay, so we're still going to do the same concept. So we're going to go ahead and do our radical symbol, and we're going to put each of these numbers underneath. So 5 times 10 times 8. So if I go through and do 5 times 10, that gives me 50. 50 times 8 is 400. Okay, so now I've got the square root. Oh my goodness, I can't draw today. Of 400. Okay, is that a perfect square? Well, we can check our calculators, and some of you will know that yes, it is. It is this 20, and then I'm going to just put my meters on there. Okay, so that's just applying some things, working with the concepts that we were out of the lesson today, maybe somewhere where it may take place. Yes, it's a more advanced skill, but I want you to keep plugging away. Remember, when you've got story problems, it's going to be tying in with the activities that I was having you practice earlier in the lesson. So the key thing out of this lesson is making sure that when you have non-perfect squares, you can simplify if they have the same label or the same square root behind them. You can simplify the numbers in front by following whatever the operation symbol is. If they ask you to break down a square root or simplify a square root itself, go through and do your prime factorization, circle pairs. Those pairs go on the outside, just writing each number once. And then your non-perfect or non-paired groups are going to go underneath of your radical symbol. Then simplifying within each of those if there's multiplication that needs to occur. Keep working through this, guys.